Hi everybody, this is Jeannie Moran and welcome to Advanced Concept Week 3 where we will be using vinegar and baking soda to create a rocket. So before I start, picture rocket engines on spacecrafts that launch a rocket into space. How does this all work? What happens to the fuel that launches the spacecraft? Well, it's a chemical reaction called combustion. Rocket engines function on the principle of combustion. So do cars. Combustion is a fast chemical reaction between a fuel and an oxidizer, such as oxygen, where the fuel is burned or oxidized. Combustion is not the same thing as an explosion. Usually the fuel is an organic compound containing hydrogen or carbon, sometimes even metals. For example, on the space shuttle, the orbiter's three main engines use liquid hydrogen as the fuel and liquid oxygen as the oxidizer. However, the space shuttle's two solid rocket boosters use aluminum powder as the fuel and ammonium perchlorate as the oxidizer. During combustion, new compounds are made, and these are called the exhaust. At the same time, a great amount of heat is produced because combustion is an exothermic reaction, which means it makes energy in the form of heat and/or light. Altogether, the combustion in the spacecraft's rockets produce great amounts of exhaust gas at high temperatures and pressure. The pressurized hot gases are pushed out from the bottom of the rocket, and thus the spacecraft is thrust upward. This is an example of Isaac Newton's third law of motion, which states that for every reaction there is an equal and opposite reaction. Mixing the fuel and the oxidizer together correctly is very complicated. Today, though, I will try to simplify this concept by using baking soda, sodium bicarbonate, or NaHCO3, and vinegar, also known as acetic acid, or CH3COOH, to make a chemical reaction that can launch a small-scale rocket. This reaction is based on acid-based chemistry, which means the reaction produces water, H2O, and carbon dioxide, CO2. So just a few important terms you'll hear during the experiment are take note of the fuel, the oxidizer, carbon dioxide, water, exhaust, thrust, Isaac Newton's third law of motion, and how all of these terms come together to thrust the rocket and launch it. For my experiment, it came up with an empty water bottle. I used 3 pencils, but you could also use straws, some duct tape, baking soda, vinegar, and cork. I used a wine bottle cork, but you can also make one out of some of the extra duct tape that you have. So let's see what happens. So as you can see, I'm out in the backyard where I have plenty of space, and I am measuring out. I personally used about 3 tablespoons of baking soda, and I put that onto a half of a paper towel, and I am now rolling that up into like a little skinny burrito-like pocket, which I am going to twist and make it as skinny as possible so that I can shove it inside of the empty bottle. This will then give me time to pour in the vinegar and place the cork on the top of the bottle before the reaction takes place. So here you see a little bit of the baking soda is dropping off, but for the most part it will be trapped in that bouncy paper towel, which I almost have in the bottle. Okay, and again, you want to make sure you're outside and on a flat surface because it is a bit messy. So next I am grabbing my vinegar, and I'm going to pour some vinegar into the bottom of the bottle. There are different measurements, and each one, the measurements affect like how far your rocket will launch, the different percentages of the acetic acid, and how much baking soda you use. And then other experiments, people do multiple launches and then measure the height and the reactions. But for this simple experiment, I'm just going to pour in about 1/3 of a bottle. Like I'm going to fill the bottle about not even 1/3 of the way, I quickly place my cork in and set it upside down and stand back, and let's see what happens. And it's bubbling up inside there, and it is about to take off. And there it goes. Boom. So let's discuss what happened. So the reaction between the baking soda, sodium bicarbonate, and the vinegar, the diluted acetic acid, generated a carbon dioxide gas, which is used in other experiments like chemical volcanoes and other projects. So let's discuss the science behind the magic. So the overall chemical reaction between the baking soda, which is the sodium bicarbonate, and the vinegar, the weak acetic acid, is that 1 mole of sodium, solid sodium bicarbonate, reacts with 1 mole of liquid acetic acid to produce 1 mole each of carbon dioxide, gas, liquid water, sodium ions, and acetate ions. And you can see how that is written at the top. The NaHCO3 is a solid, S is for solid, plus CH3COOH, L is for liquid, uh, turns to the CO2, which is a gas, H2O, liquid, plus the Na plus equals aqueous, or in water, CH3COOAQ, again, forming that gas. So this equation usually occurs in 2 steps. The first is called double displacement reaction, where the acetic acid and the vinegar soak through the paper towels, reacting with the sodium bicarbonate, and then it forms a sodium acetate and a carbonic acid. And again, here I have this listed out. The carbonic acid is an unstable and solution, and it then undergoes a decomposition reaction, producing carbon dioxide gas. And here's the equation for that. So next, the carbon dioxide escapes the solution as bubbles, and that's where you see all of that foam pushing against the corks. And because the bubbles are heavier than the air, the carbon dioxide gas collects at the surface of the container, building the pressure. So, simply put, the gas rapidly left the water and in turn created lots of foam and bubbles to try to force its way out of the bottle. This cork prevented the CO2 from immediately escaping the bottle, but also caused a rapid increase of pressure inside of the bottle. The pressure builds to the point of the cork no longer containing the gases, and bam, the cork and its contents of the bottle explode through the opening. The bottle contents shot downward and the bottle itself shot upward. How did that happen? Well, this is Newton's third law of motion, as we mentioned before. It says that for every action, there is an equal but opposite reaction. The initial action was the rush of the material, that one-way force out of the opening that pushed hard against the air behind the bottle. The opposing reaction was the air pushing back with the same amount of force going the other way. The bottle was then thrust forward as rushing foam and gas shot backward. Thank you for listening. I hope you enjoyed. And if you have any questions, feel free to make a comment below.